All right, let's talk about empirical formulas and how ratios can help us get these empirical formulas for compounds. Okay, so I can be given, someone can do an elemental analysis. Maybe they burn something or something, and they can tell me the percent of each of the elements that are present in the compound, and from that I can determine the empirical formula. And I'll just remind you from our previous discussion, an empirical formula is not necessarily the formula of the compound, but it tells me the ratio of the elements within that compound. Okay, so H2O, for example, is both the actual formula for H2O and its empirical formula, because the subscripts for H2O are at their reduced form. If I look at hydrogen peroxide, right, which you can, it's a common product at CVS or something, it's H2O2. That is the actual formula, the molecular formula for H2O2 is H2O2 for hydrogen peroxide. The empirical formula is, well, I have to reduce these 2's into 1's, and it'll be HO, H1O1, I guess, HO. And the empirical formula just tells me the ratio, the mole ratio of the elements within my compound. That's all. So I'm going to be able to find this based on gravimetric analysis. So the weight analysis of my compound. So let's look at this particular example. I want to know, given someone did this analysis and they came up with 17.5% sodium, 39.7% chromium, and 42.8% oxygen by mass, and they want to know what is the empirical formula of this compound. Now again, I will have this here for you solved out, so you can go back and refer to it later, but I will do this by hand with you so you can see it being done as well. So you have both options. So again, I'll write that here for us, and then we'll try to do that. 17.5%, these are by mass. Na, I have 39.7% chromium and 42.8% oxygen. And the question is to find empirical formula. So what the ratio of these three is to one another. Now I'm going to prescribe here a recipe that you can follow whenever you're being asked to find the empirical formula of anything given these percentages. If you follow this recipe, you will always get the correct answer. So first step number 1, use 100 grams as your basis. What do I mean by that? Multiply these percentages by 100 grams, right? Because these are by mass. So if I just assume I have 100 grams, that means 17.5 grams is this, 39.7 grams is this, and 42.8 grams is this. So basically it will be 17.5% of 100 grams. If I take this guy here, and I get that this is 17.5 grams Na. If I look at the other ones, it's the same exact thing. 39.7% of 100 grams will give me 39.7 grams of chromium, and 42.8%, same thing, will give me 42.8 grams of oxygen. So I have these now in grams. Great. Step 2. I have everything in masses. Use the molecular weight from the periodic table and convert all the masses into moles. Because as we've shown before, when you're looking at any formula, any molecular formula whatsoever, the subscripts tell you the mole ratio. So we're going to get the mole ratio. That's what we're doing. So if you look at the periodic table, Na is 23. I'll just write that here in red, so you see why I'm doing what I'm doing. Na is 23. Oxygen is 16, and chromium is 52. Okay, so if I were to convert these three up here to that, 17.5 grams of sodium. Okay, and I want to get rid of grams of sodium and go into moles of sodium. So I'm going to put grams of sodium here and mole of sodium here. And the periodic table, that 23 I see there, this has a hidden unit. Always put that in there for you in your mind. Grams per mole, grams per mole, grams per mole. The 23 goes with the grams. So I will put the 23 here. The 23 goes with it, and per 1 mole. And that is how I get that this here is going to be 0.761 moles. You can write MOL as shorthand for moles. I know you're just dropping an E, but people do that all the time. And this is 0.761 mole Na. Okay, so we got that. Very similarly, I will do the other guys. 39.7 grams of chromium. Again, I need to find my conversion factor. Well, that's just my molecular weight. The only question I have here is, do I put the number from the periodic table at the top or the bottom? And you just easily find that by seeing what you're trying to get. You're trying to get to moles and out of grams. So I want to put grams at the bottom, grams of chromium, and moles of chromium at the top. This is 52. Again, 52 grams per mole. So the 52 goes with the grams. And this is 1. And if I were to multiply that together, that's 0.763 moles of chromium. And then very quickly, I'll just do oxygen. Hopefully you're getting the hang of it. So it's 42.8 grams of oxygen. Oxygen is 16 grams per mole of oxygen. And this ends up being 2.68 moles of O. Okay, so again, this looks much longer because I'm doing it very slowly, but when you do that, it's quick. Okay, so now I converted everything to moles. So that's step 2. Step 3 out of 5. Step 3 here is to divide all of these moles that we found, all these mole figures. So 0.761, 0.763, and 2.68. Divide all of these numbers by the smallest figure. So what's my smallest here? This. So I will go 0.761 divided by 0.761, 0.763 divided by 0.761, and 2.68 divided by 0.761. So let's do that. So I have 0.761 divided by 0.761. And that ends up being 1 mole of sodium. 0.763. And I should actually do this. I'm sorry. I'm going to maintain my sig fix. My apologies. This is 1.00 moles of Na. 0.763 divided by 0.761. That also ends up being 1.00 moles of chromium. And lastly, so you don't get confused here, 2.68 divided by 0.761, that ends up being 3.52 moles of oxygen. Okay. So that's step 3. I divided everything by the smallest thing, and hopefully you're starting to see what I'm going for. I'm trying to get them to be all whole numbers. So I don't have them as whole numbers yet. I have, this is 1, this is 1, this is about 3.5. It's okay to approximate here. because this is based on experimental numbers, and so obviously they have some mistake, an inherent mistake whenever you're measuring anything. So it's possible that this 3.52 is actually 3.5. It's okay. So we'll assume that it is 3.5 about. Okay. So step 4 in my quest here. Right. Step 4 is you multiply the numbers you just got from step 3. Okay. Multiply the moles from 3 by the smallest whole number that yields integers, that transforms the figures into whole integers. Okay, so basically I had 1 from Na, 1 from chromium, and 3.52 of oxygen. What I will do now to try to get them all into integers is multiply everything by 2. Okay, and when I do that, I get 2 Na, 2 chromium, and about 7 oxygen. Okay, it's okay. 7.03 or 4, whatever. That's going to be close enough to 7. Step 5 is the shortest step. Is use these as the subscripts in your empirical formula. You're done. So my empirical formula is going to have Na in it, chromium, and oxygen, and I need to figure out what subscripts are. So there they are, 2, 2, 7. And if you Google this is an actual compound. This 7 looks a little funky. There you go. That's how you do percent weight. And so if you follow this recipe, you'll always get this right, and it's okay to approximate to some degree.